Hello there and welcome to Lower 6th Further Maths A-Level Pure Core 1 past paper, June 2015. This question is a question from FP2 in June 2015. It's only part of the question that refers to this module. So we have z equals minus 2 plus 2 root 3i. Find the argument and modulus of z. So going back to basics here, the modulus of a complex number be minus 2i plus, so we up here, refers to the distance on an Argand diagram from the complex number to the point 0, 0. So it's the square root. We use Pythagoras theorem for this one. Base squared add height squared. So that would be 2 squared add 2 root 3 squared, which is going to equal the square root of 4 plus 2 squared is 4 times 3 will give me 12. So the square root of 16 here is 4. So the modulus here is 4. And the argument, well, first of all, before we work out the argument, we want to work out this angle round here. Now the base here is 2, the height here is 2 root 3. So we can use tan on that right angle triangle there to work out that angle. So tan minus 1 of our opposite over adjacent, 2 root 3 over 2. That's tan minus 1 of root 3, which is pi by 3. However, that's not the answer to the question. Now, our question wants us to find the argument, which is this angle round here. So the argument of z is equal to 2 pi by 3. We can just check this on our calculator, go to the complex number mode, type your complex number in, press equals, and then using the option button, go down once and clicking R theta mode. Just here we can get our answer turned into modulus argument form. The 4 here corresponds to the 4 is the modulus, and 2 pi over 3 corresponds to the argument. So that's nice and easy. Okay, find z to the 6, simplifying your answer. Now, instead of expanding this complex number out 6 times, what's going to be easier to do is to do it in argument modulus form. So it's going to be 4 times cos 2 pi by 3 plus I sine 2 pi by 3, and these are going to be multiplied together 6 times. So in other words, this complex number here is going to be to the power of 6. Now what we can do here is we can do 4 to the power of 6 cos, and with the arguments, instead of multiplying the arguments together as you go along 6 times, you add the 6 arguments as you go along. Or in other words, it's 6 times this argument here. So this is going to be 12 pi by 3. Add I sine 12 pi by 3. 12 pi by 3 is 4 pi, which is the same as 2 pi, which is the same as 0. So this can effectively be a cos of 0 plus I sine of 0, or in other words, a 0 argument. And 4 to the power of 6 is 4096. We can also go back to our calculator mode and just type in our answer from before to the power of 6 and get 4096. It's in I mode, it's in complex number mode from the menu button there, so it will have given us it in complex number mode if it needed to, but it's just the value 4096, no imaginary parts there because we've got a 0 radians there. So it's going to be 4096 along the real axis up and down by nothing. Okay, great, 5 marks for that.